Alright, so what we're going to do is we're going to figure out how to graph this thing using all of the tools that we've learned. We're going to be given this thing in factored form because, to be honest with you, there's I told you there's standard form and there's factored form. Standard form is not really that useful at all. Factored form is always way more useful for graphing purposes, at least. Actually, factored form is way more useful for every purpose, to be honest with you. Alright, let's take a look at this and we'll see what we can do. Now, first thing, if you want to find, the best way to find what a graph looks like is you look for the asymptotes. The best way to look for the asymptotes is you look for, there's two different types of asymptotes. There's the vertical ones and the horizontal ones. The vertical ones you'll get from the domain problems. If it's a fraction, then you'll definitely say, well, where does this fraction equal to 0? And wherever that fraction equals 0, that's where you're going to get probably a vertical asymptote. The horizontal asymptotes come from making x be a really, really large number. If x is a really, really large number, then you play that game where you only take the leading coefficient. After you get that, if you want to get some of the more specifics of this thing, you find plug-in points. Now, the way that we've always found, even when I was teaching you about straight-up lines, if you want to find the x-intercept, you plug in y equals 0. If you want to find the y-intercept, you plug in x equals 0. It's that straightforward. So let's do this problem to ad nauseam. X minus 1 over x minus 2 times x plus 3. Now, the first thing is my vertical asymptotes. Vertical asymptotes occur when this is equal to 0 or this is equal to 0. Basically, the entire denominator is equal to 0, but when the denominator equals 0, that only occurs when this first thing is 0 or the second thing is 0. So, either x minus 2 equals 0 or x plus 3 equals 0. Usually we say cannot equal to 0, and that's actually true too. X minus 2 cannot equal to 0 because if that were true, then that would make this thing 0 and that would be a domain problem. So x cannot equal to 2 and x cannot equal to negative 3, which actually tells me my vertical asymptotes, because that means that at negative 2, or at positive 2 and at negative 3, I have a problem. This is x equals positive 2, and this is x equals negative 3. Alright. Now what I'm going to do is I'm going to look for my horizontal asymptotes. Those ones are pretty straightforward too. Let's see. What you do is you want to let x go to infinity. So essentially your numerator, the leading term, is just x, whereas the denominator, your leading term, is going to be x squared. And so that's going to basically reduce down to 1 over x. I know what the graph of 1 over x looks like. It looks like this. So I know that my graph is probably going to graph something like this. And the horizontal asymptote in this case is x equals 0. Or the horizontal asymptote in this case is x equals 0, or y equals 0, I'm sorry. So this graph gets closer and closer to 0. It never touches it, though. I guess the next question I need to ask myself is, what kind of vertical asymptotes are they? Are these even or odd asymptotes? Because that tells you how the graph will jump across those vertical asymptotes. If this were an even number, like this were a square up here, then as this thing approaches this thing, this would go up to infinity, and then it would come up to the same infinity over there. But this is not an even number, it's an odd number. See, there's actually no number there, which implies a 1. So that would mean that as this thing goes up to infinity, this thing jumps from here, goes down this way. Now, don't get me wrong, there's nothing saying that the graph can't cross the vertical or the horizontal asymptote. Remember, it's the vertical asymptotes that you can never cross, but the horizontal asymptotes you can totally cross. It's just as it goes out to infinity, your graph has to end up, going towards that thing. Same thing over here. This is an even or an odd asymptote, so I know that it's going to jump like this. Another thing too that I want to figure out is what are my intercepts. So let's plug in x equals 0, that's pretty easy to plug into here, to my actual original equation. So at f of 0, I have 0 minus 1 over negative 2 times 3. So yeah, just plug in 0 for x. So that ends up being positive 1/6. So my y-intercept is positive 1/6. Okay, fine. I'm going to ask what is the x-intercept, and I'm betting that if it comes down over here, I bet you that x-intercept is going to be positive. Let's check. So to find the x-intercept, you set this whole thing equal to 0. If that equals 0, then I can multiply through by that denominator, and those basically die. And so I end up getting x minus 1 equals 0. Okay, so x is equal to 1. That's my horizontal intercept, my x-intercept. So it's at x equals 1. Which I knew it would be positive, because if this graph came up and had to cross the x-axis, it would have to cross at the positive side if it wanted to cross over here. What I mean by that is I couldn't have had it cross at the negative side and then cross here, and then cross here, or something like that. That doesn't make sense. I knew this x-intercept had to be positive something. So I'd venture to say that my graph looks something in general like that. Let's go down to Desmos and we'll check it out. Let's put in our vertical asymptotes. Let me just go back to the home screen. There we go. Alright, so I said that the vertical asymptotes were going to be at, was it 2 and negative 3, I think? Okay. I also said that my horizontal asymptote was going to be at 0. Alright, so those are my guidelines. This is the previous graph. Please disregard that. Alright, so I've got my fraction, and I think it was x minus 1, and on the bottom I have 2 parentheses, and it was x plus 2, no, it was x minus 2, x plus 3, yeah. X minus 2, and x plus 3, x plus 3. There we go, look at that, look at that, look at that. That's exactly my graph, isn't it? See? I have almost exactly that. I mean, granted that the shape doesn't look exactly the same, and if I wanted to get maybe how that curve exactly looks, I could plot points and whatever. But the point is, the key features to my graph, it's x-intercept, it's y-intercept, it's x-intercept, the vertical asymptotes, the horizontal asymptote, they're all correct. I was able to graph this function just by looking, or just by figuring out key features and being a detective about it, as opposed to just kind of plugging it into my calculator and seeing what the graph looks like. I think that's cool. I think that's powerful. That's the level I want you guys to get to. Alright, so practice that. Hopefully that works.